Okay, greetings again, geology students. Hope you guys are still doing okay. Um, Wanted to do another brief recording for you. I guess in this format, it's the form of a lecture, which is not my favorite, but wanted to show you some things having to do not just with the large group of galaxies, the large perspective that we've been looking at, but actually zooming in, focusing in on just our own home, the Milky Way Galaxy. Okay, so I'm going to give you sort of a perspective on our galaxy, maybe in a way that you haven't seen it before. Hopefully, this is new to you. But I'm using Starry Night once again to do this visualization, and so hopefully you enjoy this, kind of like you might enjoy sort of a planetarium. Okay. Okay, so we take a look at our view of the night sky. Okay, I'm zooming out a little bit. There should be this sort of like 360-degree view, um, panorama, or whatever you want to call it, of the sky, and moving right through the center of this is what we have as one of the arms of the Milky Way Galaxy. Okay, I'm going to bring the horizon up, all right, at this time, so we can take a look at a perspective of, yeah, that this is a sort of a mountain of clouds, if you will. Clouds in the form of gas and dust and individual stars, but this is one large arm of the Milky Way. Okay, one of, well, the textbook teaches that there are four arms. That's kind of the official number. And a lot of these numbers that I'm spouting off, they actually, as new research comes out, that they do change fairly regularly. So I'll tell you which numbers to commit to memory for the time being. But it is kind of frustrating sometimes with the wide variety of numbers that happen, which is why the internet's the best thing, and not just going by a textbook, which gets kind of quickly outdated. Right? That's all I'll say about that. But this is one arm of our barred spiral galaxy. Okay, every every star that we see in the sky, okay, is inside of our own galaxy. Right? This one here, it the data might or may not show up very well, off to the side in blue as soon as I process this and post it. But it says that this star here, it's kind of randomly going around. The star is 673 light years away. This star is 759 light years away. This star right here is, um, it's an unknown object. Um, Not giving, okay, 384 light years away, 78 light years away, okay, 148 light years away, 210 light years away. So 37 light years away. These are all in our own kind of immediate galactic neighborhood. Okay, so those are pretty close by, um, and so that's kind of what we're looking at. So we are all in the midst of this arm, right? This arm, and so we're all in this haze, if you will, as this is all a continuance of the haze of that arm that's pointing outward that direction. Okay, so I'm going to go now. Now, taking a look at a deep sky object. Okay, I mentioned yesterday in the last video that I posted on about a galaxy that I wanted you to be aware of called M31, the Andromeda Galaxy. Okay, if I were to zoom into the M31 Andromeda Galaxy, that's what they say is the most distant object that you can see without binoculars. But I've never seen it without binoculars or telescope. But yeah, so here we are, 2,900,000 light years away. So that one is way outside of our galaxy. Okay, it is well beyond. It's a deep space object. It's so it's not hovering around our local group of stars. Kind of like basically everything else is. Everything else is in sort of our immediate area. Okay. Okay. So taking a look at specifically, the constellations. All right. So here's our perspective too, and so we want to use constellations sort of as our guideposts. Okay. Zooming back out, stopping their movement. Okay. If I were to draw up their okay, the shapes, if you will. Now you can see how, a bunch of familiar ones. Those are basically, our immediate neighborhood, okay, and the perspective of where other objects are in the night sky, okay, and that's what we use constellations for. They're basically landmarks. They're basically, for the most part, yeah, they're good for mythology. They're good for storytelling, but for scientists, largely they're good for saying, okay, we look in the direction of Hercules, okay, and we can see a really important object that you're going to learn. I'm glad I actually found this and I'm pointing to this now. We're learning about something called a globular cluster. Okay, this globular cluster is is still technically in our own galaxy. It's really, really far away at 25,000 light years in distance. Right, so there are tens of thousands of individual stars in this one star cluster. Okay, so that's called a globular cluster. All right, so it's known as the Great Hercules Cluster because it falls in the constellation Hercules. Um, so that's the benefit of the constellations. Okay, all right. So going back to all right. So one more perspective I wanted to show you before I send you off and to do your assignment for today. We have this perspective, which I love, of the larger Milky Way. Okay, and you have you stop this a little bit. Okay, and so the arms that you're seeing here. Okay, uh, officially there are four arms. So some of them are actually offshoots. They have what's called a spur. Okay, you and I live and I wish it were labeled, live in an arm called the Orion spur, which is part of a larger arm called the Perseus galactic spiral. Okay, so this is our location. Okay, we are located. You need to know that we are 26,000 light years from the central region. Let me put this back in. Let me actually reopen it back up originally to what it should look like. Okay, so the center of the Milky Way, which is they don't show the bar very well, but it's called a barred spiral galaxy. Okay, and this barred spiral in the middle portion. Again, I'm just frustrated why they would use this image because they don't show the bar very well here. But the bar is actually 27,000 light years in diameter itself. Okay, but from the very center of the Milky Way to the sun in the Orion spur of the Perseus arm of the galaxy is 26,000 light years. Okay, we talk sometimes about the Goldilocks zone, and that's the zone where things just seem to be just right to be able to house life. Conditions are good for habitation or something, or the factors that we've been learning. But that's so we're 26,000 light years from the center. Okay, and in the galactic core, okay, the middle area known as the nuclear bulge. Right, the nuclear bulge. Those stars are actually 1,000. It looks like this dense, impenetrable light source. If you look at it from some perspectives, but it's actually individual stars that are in this area are still 1,000 astronomical units away from one another. Okay, whereas here out where we are near the sun, okay, these individual stars around are end up being like 200,000 astronomical units from each other on average, and so it's like it's a few light years away from one another. Okay, so coming back out though, you mentioned light years and distances. The textbook says that the diameter of the Milky Way is 100,000 light years across. Okay, 100,000. It would take light 100,000 years to go from one end of the Milky Way galaxy to the other end. Okay, that is just a colossal size. However, the paper that I posted for you explicitly says 130,000 light years. And I was researching this morning actually, and the latest numbers say that that the diameter of the galaxy can be up to even 200,000 light years. Okay, so when it comes test time, um, I might give you multiple choice options, in which case you could, you know, pick one that most reflects. I don't know how I'm going to spin that, quite honestly, just because, like I said, the variety of data that's out there and the numbers makes my head spin. All right, but yeah, so as late as like 2015, though, this this data is telling us that up to 200,000 light years across. Okay, so anyway, it's big. That's the moral of the story. It's big. Not only that, let me see if I can just start this up again. But not only that is the Milky Way is spinning at the same time. It's spinning like a top, and and it takes the sun about 225 million years to go around the Milky Way one time. 225 million years. Okay, so we could turn that into a math problem if we wanted to, based on the diameter of the Milky Way, if we actually knew what that was. Um, but it takes 225 million years, which basically, whenever the dinosaurs started walking on the Earth, that's the last time that we were in the same position around the galactic core. Okay, 225 million years ago, and that means even since the sun has been, or the Earth has been around, it's only in its 4.5 billion years. Okay, well, actually, the sun being 5 billion years old, it's only gone around the galactic center 20 times in its lifetime. All right, so there's some perspective for you. The Milky Way. I hopefully you learned something new. Um, so take a few notes on this if you haven't already, and that'll be it for today, folks. Post something new tomorrow. Have a good day.